As athletic trainers, we deal with injuries, first aid, emergency care, and rehab. For our project, we collaborated different types of football functional training techniques that demonstrate the laws of motion. Newton's first law states that a body at rest remains at rest, and a body in motion stays in motion until acted upon by an outside force, also known as inertia. Inertia is the tendency of a body to continue in its initial state of motion. This video, the football player starts in a stable position. He will remain in this position until acted upon by an outside force. In this situation, the outside force is his right leg that is applying a force against the ground. The potential energy of this leg is transferred into the ground, allowing him to change stages of motion. He will stay in this state of motion until another force is applied. This other force is again the potential energy of his right leg against the ground, allowing him to change direction. This is repeated until the drill is completed. Newton's second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. In our video, Newton's second law is demonstrated in the force it takes to stretch a TheraBand a certain length. Acceleration is the rate of which the athlete stretches the band. The net force is the act upon the object and the amount of force applied by the athlete. The mass of the object is the amount of force it takes to stretch the TheraBand apart. The athlete is using a 10-pound TheraBand, which means that the athlete must apply 10 pounds or greater to stretch the band. The athlete must apply a correct amount of force and acceleration to stretch out the band to perform this drill. Newton's third law states that whenever a body exerts a force on another body, the latter exerts a force of equal magnitude in opposite direction on the former object. These coupled forces are called an action-reaction pair. In this video, there is an applied force on both ends of the tire. When one end applies a greater force, it is translated into a reaction on the opposite side of the tire. Kinetic energy is energy that is in motion. Potential energy is when energy is stored. In this video, the athlete is performing jump ropes. This is an example of kinetic to potential energy, then potential to kinetic energy. As the athlete is jumping up, he is using kinetic energy. As the athlete reaches the apex, he has built up the maximum potential energy. When the athlete returns back to the ground, the potential energy is transferred to kinetic energy. The center of gravity is the average location of the weight of an object. In this video, his center of gravity remains constant and is the point of which he has to get over the bar.